Good evening, folks. This night we'll be doing an EDA on the Kaggle dataset, Caffeine Intake Tracker. So first things first, our intro. Coffee may provide us with energy to get on with the day, but too much caffeine can often make sleep a casualty. This analysis explores the effects of caffeine on sleep quality and focus. And no, we'll not just be focusing on coffee alone, we'll also be exploring other drinks as well, such as tea and energy drinks. Okay, now a feature description of the dataset. Uh, One main thing to note is that the continuously variable numbers in this dataset has been normalized on a scale of 0 to 1. This would help make our analysis easier. Okay, so first variable is caffeine in milligrams. This, like it's obvious, states the amount of caffeine consumed in milligrams, the age of the participants, the focus level, self-reported concentration levels among the people after caffeine consumption, self-reported sleep quality, and a binary indicator of whether they believe that their sleep has been impacted or not by caffeine. Up next, these three variables are for their beverage of choice, which includes coffee, energy drinks, and tea. They are Boolean values, which means they only take the form true or false. True means that they have consumed this said beverage. False means that they are consumed something other than the mentioned beverage. If, for example, in the variable column, for true stands for the person having consumed coffee, false standing for that person having consumed something other than coffee, which could be either energy drinks or tea. And the next three variables stand for time of day, afternoon, evening, morning, and the last two variables are for gender, female, male. Our first step towards our analysis, like the obvious step would be to load the dataset. Here we use the command data read.csv to load the dataset, caffeine intake tracker.csv. And next we load the necessary libraries. We use the library Tidyverse in most of our analysis tasks because Tidyverse is a collection of R packages designed to make data science tasks easier and consistent. It provides a set of tools for data manipulation, visualization, and analysis, all which share the same core philosophy and structure. Main packages to focus would be dplayer, which we use for data manipulation, and ggplot, which we use for data visualization. Okay, so after loading the necessary libraries, we convert our data frame to the form of a tibble, because Tidyverse prefers to work with tibbles rather than the standard data frame. Okay, to view the dataset, this command slicehead is a part of the Tidyverse collection. Okay, we use the command slicehead parenthesis data n equal to 10, n being the number of rows we wish to display. If we do not mention any set number, Tidyverse would only display one row. Okay, so here we can see that this tibble generated. These are the main columns: caffeine milligrams, age, focus level, sleep quality, sleep impacted, beverage, coffee. And as the table is a little on the wider side, the other headers have been crammed here. Okay, slice tail function shows us the last 10 rows, while head gives us the first 10 rows. Tail is the polar opposite, it provides us with the last 10 rows. They display the data in the same format. Moving on, next we come to the glimpse command. The glimpse command gives us a quick snapshot of what our data is like. So here we can see that we have 500 rows and 13 columns, and these four variables, the ones which I have selected here, they come with the tag DBL, right? DBL stands for double precision. which is the same as floating point numbers in Python, decimal point numbers, uh, continuously variable decimal point numbers. So these four are our continuously variable data. This is an integer column, but we should read this sleep impacted column such that the values are like yes and no. Okay, 0 stands for sleep impacted no. 1 means that their sleep has been impacted. And in this data set, all the other columns go with Boolean values, which means they can only take two forms, either true or false, yes or no. Okay. Up next, we use the command summary data to get an idea of how our numerical columns are distributed. This command doesn't uh, give us any useful information when applied to characters, like character columns. If you can see here, the beverage column, it only tells us the number of rows and the mode. Okay, like yeah. So here we can see that this this is the distribution of our data. Min values are all 0 except for here, and max values would obviously be at 1 because they are normalized on a scale of 0 to 1. And we can see where the median and the mean where they all fall. Okay. Up next, we use the command call names to view the column names. Um, we use this command often while working on the file because uh, at the end of the day, we have to copy paste a column names uh, to inside the lines of code we are working, right, to display our variables, columns, data properly. So we use this command quite often while working on the file. This tells us all the headers of our dataset. Up next, a very important thing we have to do, well, we have to check whether our data has any null values or if there are any duplicates in the dataset. So for that, we use the command data pipe operator is .na pipe operator sum. This pipe operator is a part of the Tidyverse collection. Uh, what it does is basically it takes whatever it is from this side and uses the result from this side inside this command. And when we chain pipe commands together, whatever is the result of this section of the code, the entire output is processed to the next section of the code. Okay, just follow my mouse along and you'll understand. And it tells us here that there are no null values in the dataset. And this is an alternate command. Call sums is .na data into 100 dim data square brackets 1. And yeah, this gives us an idea of how the null values are distributed across the various variables. And if there were any null values in this data set, we would be able to pinpoint in which column they occur. Okay, yeah. And you can see that there are no null values in the data set. Up next, we check for duplicates in this data set. Data, pipe operator. We filter it to show only the duplicated rows. Okay, data, pipe, filter, parenthesis, duplicated, parenthesis, dot. Okay, and it tells us here that this table has 0 rows, which means that there are no duplicated rows in this data set. An alternate command here would be duplicated data pipe operator sum. This gives us, like, this tells us the sum of all the null values that are in the data set, which is also 0 here. Up next, we'll be seeing a very important command, which is a part of the Tidyverse collection, that is mutate. Mutate is a function of the deep layer package, okay, and it is used to create a new column, which is done by modifying an existing column inside the data frame. It returns the original data frame with the modified new columns added. Okay, so here I've noticed that we don't really need these two columns like this, right? Gender female and gender male, okay, because they return true or false. I've checked some of the rows, and in the gender female column, if it's true, that person identifies as a female, and if it's false, that person identifies as a male. So I thought about mutating this column to a single one. So here we are reassigning this to the original data variable. Okay, and data pipe operator mutate this gender equal to part here. This would be the header of the column that is going to be born from this this command. So gender equal to recode. This recode function is used to replace specific values inside a column. Okay, and here I am telling it to look inside the gender female column, and where there is true, it should be female, and wherever the values false appears, it should be male. And from here we are displaying the data set slice head data n equal to 5, and we can see that gender female, gender male, and there's a new column here, gender. See, we have 14 columns now, whereas it was 13 here, right? Yeah, 13. So yeah, this is our new column, which is just gender. Okay, and yeah, so to drop these two irrelevant columns, we'll be using the command data pipe operator select minus gender female comma minus gender male. This is how you drop columns inside R, and we'll be reassigning this to the original table. And here we can see that the two columns are no more, and we are just left with our new column, gender. Up next, data filtering. I thought it would be useful to filter the data for some visualization tasks. So I filtered it on the basis of those who believe that their sleep has been impacted and whose sleep has not been impacted. So here we can see that I've used the command data pipe operator filter sleep impacted 1. We pass it on to the pass it on again by another pipe select -5. This command here is telling R to drop the 5th column of this data frame, of this table. Sorry. So otherwise, we would have a column where sleep impacted is 1. Like we know the only value that displays there would be 1, right? So there's no point in showing it again. It just clutters up our workspace. So it's always a good decision to drop irrelevant columns where possible. So here I have assigned it to a new variable sleep impacted yes, and another set of people who believe that their sleep has not been impacted by caffeine intake. Okay, moving on. Now we get to the visualization part. Visualization charts help us to understand how data is in a very quick manner. Okay, so we use the command options rapr plot.width equal to 6, comma rapr.plot.height equal to 4 to set our workspace. This command determines the size of the charts, and it is one which we'll be using quite often. So yeah, our first chart is a histogram. We've used the command ggplot data aesthetic layer x equal to age plus geom histobar bin width equal to 0.05. Bin width sets the axis here. If bin width were some preposterous number like 1, we'd have one single scale here. Like it would make no sense, and the chart would look very weird. Okay, so bin width equal to 0.05 plus labs labels title equal to distribution of age. Here we can see that the age variable has a very uniform balanced distribution, as one would expect. Like it is a very balanced uniform distribution. So yeah, that's it. um, Next we'll be looking at the distribution of caffeine consumption, and here the data is right skewed. So from this we can understand that uh, more people on average consume less caffeine, but there are some people who are consuming way above the average, like super over the top. Okay, so most consume little, but there are a few who consume a lot of caffeine. As we explore this data set more, we will know who those people are. Next, distribution of focus level. This data is highly left skewed. A lot of people, many consider that their focus levels are very high, but there are a few who report that they have low focus levels. Okay. Up next, sleep quality. This is also a little left skewed, but it's not to the extreme level of a focus level variable. Many people get a good quality level of sleep. Some get exceptional sleep. They've rated themselves on the highest possible score there is, but many there are a few who suffer from lack of sleep. Up next, our count plots here. If you remember, our sleep impacted variable consisted of only zeros and ones, right? So here inside the aesthetic layer, x equal to, I've used the command as dot factor to convert this uh, integer variable to a factor. And with that, we are able to use the command scale x discrete and set labels for 0 to appear as no and 1 to appear as yes. Okay. Otherwise, this chart would appear on a scale of 0 to 1, just like how these charts are presented, which would make no sense, right? And yeah, this in this manner, it's a lot more presentable. So around 300 people that believe that their sleep has not been impacted, but close to 200 people say that their sleep has been impacted by caffeine. Okay, that is what this chart is telling us. And also, if you notice here, I've used a blank space here where the y-axis labels are supposed to show up because if this were not present, the chart would generate a random, not a random, the chart would just show the text count here, which I thought was not really presentable for this type of chart. Whereas for histograms, it doesn't feel that odd. Okay, and yeah, moving on. From this chart, we can see that coffee seems to be the most popular source of caffeine in this data set. Like more people prefer caffeine over all the other drinks. Okay. But energy drinks have the most niche following here. Only a select few people seem to prefer them. Okay, like the difference is night and day. Like, not even 50 people prefer energy drinks according to this, right? Whereas over like 450 people would rather have anything else than energy drinks. Tea falls somewhere in the middle. Like people are not really against it, but the fanfare experienced by caffeine is not by coffee is not really present here, right? Okay. Up next, we are checking if there is some sort of correlation or relation between gender and caffeine consumption. Here, I've used the filtered variable that we have assigned earlier. Sleep impacted yes, and y equal to gender. And with that, yeah, I've we I've used it to check whether there is any correlation between gender and caffeine. Yes, sleep impact. My apologies. So here we can see that females report that their sleep has been like more females on average report that their sleep has been impacted by caffeine. But if you look at the other side of the table as well, more females say that their sleep has not been impacted by caffeine. So we can say that there isn't really a strong link between the two, right? There should have been some difference. If they're the same, like doesn't hold up. So yeah, there isn't a strong link between gender and sleep impact from caffeine. Up next, uh, coffee consumption by gender. Here, one noteworthy thing is I've used the command position equal to dodge to display this bar chart as a clustered column chart. Okay, by using the command dodge, these bars would appear side by side instead of on top. So yeah, coffee consumption by gender, we can see that females seem to prefer coffee more than males. It's very apparent here, right? With energy drinks, both sides of the camp uh, seem to have some, distaste for it. And both sides are not really for energy drinks, which is to be expected because like barely 50 people in this data set seem to prefer energy drinks in the first place, right? So yeah, and with tea, these it's same as the earlier chart. It's somewhere in the middle. Okay. Up next are density plots. Here, I've used the one like this section of the code for most tasks would be the same, right? So I'm not going to go over it again and again. And yeah, I've used the command geom density alpha equal to 0.5 to have, adjust their transparency, which is how we are able to create this beautiful effect here. Otherwise, they would just be blobs of color. Okay, so caffeine distribution T versus those who are not for T. Uh, if you notice here, the T camp, their caffeine consumption is on the lower side. Okay, because this graph is on this side of the chart, right? This is where the people who don't intake a lot of caffeine fall on. But if you look at the coffee part, we can see the shift. People who drink coffee, they're towards the middle. Some of them are taking in more caffeine and some are taking in less caffeine, but they are, the middle of the bunch. The difference is stark when you look at the energy drink camp. Like the caffeine addicts are on this side. Okay, like people who are taking in the maximum amount of caffeine, they seem to prefer energy drinks. Okay, yeah. So if one wishes to reduce their caffeine intake, tea is a good option, and cutting down on energy drinks is also another wise option. Up next, we are moving on to scatter plots. Here, yeah, for this section, I have assigned sleep quality to the x-axis, caffeine mg to the y-axis, and mm, I've used the sleep impacted as a sleep impacted variable, converted it to a factor, and we use the labels no and s for them. Okay, those who have rated themselves as having their sleep impacted no and yes. So here we can see that the higher the caffeine consumption, the lower the sleep quality. And people who intake a lot of caffeine, they have it really is affecting their sleep. Okay. Yeah, the regression line uh, here really helps us understand the data at one quick glance. uh, One moment please. Okay, up next, focus levels in caffeine consumption. focus level is on the y-axis and caffeine consumption is on the x-axis. And here we can see that the most focused people in this data set, they seem to be caffeine addicts. Okay, they are taking in a lot of caffeine. And the higher, like in this data set, people with high levels of focus have high consumption levels of caffeine, and the vice versa is also true. People with high caffeine consumption, yeah, people with high caffeine consumption have high focus levels, and those who don't, like those who focus levels are on the lower side, they take in less caffeine. But the majority of the data falls in the middle. Like there are both sides of there are people on both sides of the camp, but the highly focused groups, they are caffeine addicts. Okay. And their sleep has been impacted as well. Yeah. Up next is the link between caffeine consumption and age, and this regression line tells us that there really isn't a strong link between the two. Okay. Like the data is scattered all over the place, right? Yeah. All we can see from this is that towards the left are the people who are taking in less caffeine, and they seem to have their sleep not impacted as much than the people who are taking in high levels of caffeine. Up next, age and focus levels. Here also the chart is very scattered, which means that there really isn't a strong correlation between the two. Yeah, age and sleep quality, same thing. And yeah, these three charts are like a story in three phases. Okay, let's look at them. So here, does caffeine source affect sleep quality? Okay, that's what we are checking out. And here we can see that those who are taking in coffee, their caffeine consumption falls in the middle, as we have seen in the previous chart. And people who are taking in caffeine, like their sleep quality, not caffeine, taking in coffee, their sleep quality is not on the best side. Like there are people who have good sleep quality, but there are other folks who are experiencing some problem. Like this one person here, like these few points here, they have rated themselves very low on the scale, and but they aren't taking in high levels of caffeine as well, right? Next, the energy drinks camp. Here we can see that people who take in energy drinks, they tend to have poorer sleep quality. It could be because they also take in higher levels of caffeine, like even the lowest points here, like they are all higher than the T camp from the earlier chart, right? So, and the extreme caffeine addicts, they are also part of this camp. So yeah, the T camp seems to be enjoying the highest levels of sleep quality there is. Okay, and they they definitely have the lowest levels of caffeine in this data set, but some people do experience sleep issues still nonetheless. Yeah. Moving on. uh, this is another story in three slides. Okay, so here we can see that um, does time of consumption affect sleep quality? This line, the no line, is fairly consistent across the three charts. But this morning yes line, it paints a interesting story. Okay, so here in this slide, I mean this chart, the angle of people who take the regression line of the people who take caffeine in the morning, it's less steep and it's more stable than the other people, right? It's more stable. But when we look at the people who take caffeine in the afternoons, these lines are more or less parallel. The difference, the stark difference is visible when we look at the people who take caffeine in the evening. Like their line takes a straight dip. So from this we can clearly say that taking caffeine in the evening is not a bright idea. It would be wise to avoid all forms of caffeine towards the evening. Whereas with morning, it might actually help sleep rather than be a detrimental factor to it. So yes, our key takeaways from this study. Coffee seems to be the most popular source of caffeine for people with energy drinks, being the least favorite. There isn't a strong correlation between gender and sleep impact from caffeine. And females are more likely to drink coffee than men. Tea provides the lowest doses of caffeine, and coffee falls in the middle, and energy drinks provide the highest levels of caffeine. When caffeine consumption increases, sleep quality decreases, and people with high caffeine consumption are also more likely to rate themselves as having their sleep impacted by it. People who have the highest levels of caffeine also report having the highest focus levels, and caffeine source does matter, and tea users report the highest sleep quality. Coffee users are somewhere in the middle, and while energy drink users are scattered and few, many report lower levels of sleep quality. And of the three major, uh, three popular times of the day to take caffeine, morning seems to be the best in order to have good sleep quality, and evening is the worst. Uh, all right, thank you, and have a pleasant day.